Hello and welcome to this lesson on couples, which is part of the Forces and Motion module for OCR A-Level Physics. So in today's lesson we're going to be looking at couples and looking at how to calculate the properties based on laws of equilibrium. So if we've been successful and we've learned in today's lesson, we should be able to explain what is meant by a couple, calculate the forces on a body in equilibrium, and then calculate the moments on a body in equilibrium. So in this lesson we're going to be looking at the following parts of the OCR A-Level Physics specification: 3.2.3 equilibrium, in particular couples and the torque of a couple. Now, a couple are a pair of forces acting on a body that are of equal magnitude and opposite direction, acting parallel to one another but not along the same line. So forces acting in this way produce a turning force or moment, and the torque of a couple is the rotation force or the moment produced. Now it's important to note that the forces on this beam are a couple producing a moment or torque which will cause the beam to rotate. So examples of couples in the real world would include turning a steering wheel, twisting a bottle cap, or turning a spanner around a bolt. Now the factors that affect torque involve the magnitudes of the forces involved, the perpendicular distances between their lines of action, and the angles of the forces. So we can say that a couple is a pair of forces of equal size which act parallel to each other but in opposite directions, as you can see in the following diagram. As we mentioned before, a couple has no resultant linear force, as the two forces cancel each other out. So this means that due to Newton's second law of motion, F equals ma, this object would not actually accelerate. A couple, however, does produce a turn effect or moment as they are acting in the same direction, as you can see in the following diagram. Now, when the force is applied, the object will rotate with a constant angular speed, but it remains fixed in the same location. Now, the size of the moment, or torque, depends on the size of the forces and the distance between them. So what we can say is that the moment of a couple, or the torque, is equal to the force times by the perpendicular distance between the lines of action of the two forces, or m is equal to F times by d. So this occurs as the two forces produce a moment in the same rotational direction. So the moments produced needed to be added together to form the couple. So we can say that the torque of a couple is equal to double the magnitude of the moment of the individual forces. So a couple is a pair of forces of equal size which act parallel to each other but in opposite directions. The moment is determined by the perpendicular distances between the lines of action of the two forces. So this means that the horizontal component of the displacement needs to be calculated if the couple is at an angle. Now the forces given might not always be perpendicular to the distance between them, so as we said before, in this case remember to find the component of the force vector that is perpendicular by resolving that force vector. Now the forces that can make up a couple cannot share the same line of action, which is the line through which the point at which the force is applied. Now to answer questions on couples, use the following technique. The first step is to identify the forces on the object causing moments. If acting at an angle, ensure the force is resolved to the horizontal and vertical. Step 2, always include the weight from the centre of mass if not explicitly stated. Then take the moments about one point. Ensure that this point is where a force is and ignore that force. Equate the clockwise and anti-clockwise moments and solve the equation based on this. Then the force, which was ignored previously, could then also be calculated using the equilibrium principle that force up equals force down. So consider the following object. The two forces in this example balance up and down, so it's 15 newtons up and 15 newtons down, so the wheel will not move up or down or sideways. But the wheel is not in equilibrium, because whilst there is no linear resultant force, the pair of forces will cause it to rotate. So what we can say is that the pair of forces act as a couple. A couple will have a turning effect but does not cause our object to accelerate. So to form a couple, the two forces must be equal in magnitude, parallel but opposite in direction, and separated by a distance d. Now the turn effect or moment of a couple is known as its torque. So we can calculate the torque of the wheel by adding the moments of each force about the centre of the wheel. So in this case, the torque of a couple is 15 times by 0.2 plus 15 times by 0.2, which is 6.0 Newton meters. We could have also found this same result by multiplying one of the forces by the perpendicular distance between them. So 15 times by 0.4 is 6.0 Newton meters. So to summarise what we've looked at in today's lesson, we've looked at the idea of a couple, the torque of a couple, and the equilibrium of an object under the action of forces and torques. So if we've been successful and we've learnt in today's lesson, we should be able to explain what is meant by a couple, calculate the forces on a body in equilibrium, and then finally calculate the moments on a body in equilibrium. So thank you for watching this lesson on couples, which is part of the Forces and Motion module for OCR A-Level Physics. Thank you so much and have a lovely day.